All right, good morning, good afternoon, good evening, wherever you're tuning in from. Thanks for joining again for another stream of F sharp and machine learning and static malware analysis. All right, just made sure that this was live. So let me see here. Just make sure I got everything. Okay, cool. Awesome. Okay. So while I got that going, let's see. So last week we left off in a place where we thought that we're pretty much done with this project, and I thought so myself as well. Um, Unfortunately, it seems like we kind of did it wrong, and I don't recall the instructions telling us or guiding us one way or another in terms of what data we should be using. So, for example, if we were to take a look at the data, right? Well, let's do two things. Let me take a look at my submission. So what I did last time was, or what we were trying to do last time was, we were trying to prepare our data and submit it so that it could be scored against all of the other submissions for the competition. Again, in this case, we weren't necessarily going to we weren't going to win anything, right? Because this was 5 years ago. The competition was no longer sort of ongoing, right? So we couldn't win anything, but at the very least we wanted to compare. We wanted to be able to see how well did our model perform against all the other submissions, right? Now, one of the problems that I ran into was that it said it could not accept my submission because it didn't have the appropriate number of rows. Hey Jim, how's it going? Morning or afternoon where you are. Um, so we essentially we were trying to compare, and it said my submission was not valid, and the reason for that was it said that I didn't have the appropriate number of rows. So if we go here and we take a look at the data, I don't believe that it tells us here, or maybe I missed it. So for each file, raw data containing the hexadecimal representation of the file's binary content without the P header to ensure sterility. And then you have a metadata manifest, which is a log containing various metadata information extracted from the binary, such as function calls, strings, etc. So this metadata, let me see here. Let me pull up. Whoops, not Visual Studio. I hope it doesn't crash. So if we were to look at the metadata, right? So here we are in our VM. So let's data drive, train data. Okay. So if we were to ls into this, right, we have two types of files. We have files with the ASM, extension, and we have files with the bytes extension. Now, the ones that we use to train our model were the bytes. And again, if we sort of put this side by side here, right? So we have raw data containing hexadecimal representation, right? So if we were to uh, take a look here, let me make it a little bit bigger. Okay, so let's take this one for example. Whoops. Let's see, can I go back? Yes. So let's take this one for example. Let's take a look at what the bytes file looks like. Okay. Can I copy? Okay. Let's see here. Less. Okay. So if we were to take a look at that, right, there it is. So that's the hexadecimal representation. That's what this is looking at, right? Now we also have the ASM. I believe we should have the ASM. There we go. Okay, so the ASM extension, right? There's that metadata that it's talking about, right? There's function calls and all types of things. So again, to train our model, we use the bytes, not ASM. And the problem with that is that there's a discrepancy. So as you saw here, right, we have this file with this name and it has the bytes, and then we have this other file here that has ASM. Now there's a discrepancy between these, right? Or at least there is in the test set. So the test set is what we're using to be able to make predictions using the train model that we created. Um, and we were trying to submit those predictions so that they can be evaluated here by Kaggle. But there's a discrepancy because there's not one to one. So there's about 10,869 or 868 actual bytes files in the test data set versus 10,873, which is what the submission expects for evaluation. So we're going to take a look at that, right? So if we go to city test data, okay. So if we were to do what is it, ls dot test data. Oh, sorry, not test data. We want anything that's we want anything. Hey, how's it going? We want anything that's bytes, right? And we want to in one line, and then we want to count the number of lines, right? That's odd. Why are they at 10,873 now? But last time, ASM. So last time that I checked this, it was different. I don't know what happened or what became of or what happened with all these files. Okay, let me see here. So let's do a little bit of exploration here. Yeah, before you join, I was walking through why I didn't. Well, I did submit results or tried to submit my results, and I'll kind of show you. I should probably sign in so that we send with your email. So I submitted it, and what happened was it seems that we may have used the wrong files to train our model. So I think it may have been wanting for us to use the ASM files instead of the bytes files, which I don't completely get. And we were just looking to see whether there were discrepancies in whether there were discrepancies. Let's see. And actually, the reason why I think that now there's 10,873 and there's an equal number is I think that maybe this time because what I did after I wasn't able to submit it was I tried to sort of clear out my train data and sort of unzip it again. And I tried to unzip it again, and maybe this time it worked, and last time it didn't unzip the files correctly, or I'm not sure what happened. But we'll see right now. So let's see here. Okay. Now let's see. I always forget my credentials for Kaggle. Let's see here. All right, cool. I'm in. So if we were to take a look at my submissions, right? There it is, right? Evaluation exception. Um, and it said, and this is what my submission file looked like. So what we're gonna try to do, so there's two ways that we can go about this. We can try this again. We can try to train a new model. And while it's training in the background, one of the things that we can do is, yeah, so here's what our submission file looks like. And this is what I submitted to, um, Kaggle. But as you'll see, in this case, there's only 10,000, where is it? It's right here. There's only 10,868. What happened? Why is my magnifier not working? Oh, um, that's odd. Let's see here. Sorry, it's just taking, like, my cursor. It's kind of frozen. All right, there we go. Yeah, so there's only 10,868 rows, which, again, if we recall what the error message was telling us, it's like, no, that's not enough. It's got to be 10,873. Okay. So what we can do is, now one of the unfortunate things about this whole thing is that I went ahead and, oh, this would kind of be the reason why it's going so slow, in addition to me streaming. So one of the things that we can do is we can sort of let this go in the background, and we can actually do some contributions to a few open source projects that I've been meaning to. I've been meaning to contribute to. I just haven't had the time. So let's try that. Let me see. The one thing that I want to make sure before I do any of this is I want to make sure that I have everything set. So let me actually open up WSL. And WSL, what I'm going to do here is, there's a few things that I want to do. I want to see what my teamwork session looks like. I want to see what my directories look like, because again, last time I kind of blew everything away and I deleted everything. So I might have to start from scratch in terms of turning the images into turning the files into images, right? So the raw bytes into images. But one of the things that I also want to make sure is I want to make sure that all of the files that are in there are unique, right? So I could actually kind of do it here. Open folder, and I want to go into stream projects, and I want to go to stamina. Okay, yeah. So I want to make sure that all of these file names are unique. So while this is loading, let's see if this. There we go. Okay. Now we SSH. So here. Wow. Okay. So CD data drive. So we saw that there were let's see train images. Okay, so we have the JPEGs here to train our model. We have the JPEGs to train our model. Do I have? Okay, so I have nothing in my test images. So that's my next step. I need to redo my test images. But before I do the test images, what I want to do is, let's see here. So I did it on the ASM. I want to make sure that they're unique. because if they are unique, the bytes files, then that means that I can each top then that means that I can use the bytes files like we originally did, right? Okay, so t process files. Okay, all right. So this is the processing of the files. Oh, but if I remember correctly, okay. So this is another issue that we ran into. So you might see images inside of the train images, right? So ls data drive test train images, right? So you might see that, but there aren't 10,000. And for whatever reason, when I'm trying to use the ASM, it seems to sort of not like what I'm doing. So if I were to do this, right, and okay, one, and then don't see, so check it out. There's only 637. And I think that the reason for that is, well, actually, I don't know what the reason for it is. It might be that the ASM files may be just way too big. But yeah. So let's try a few things. First, let's try. Let's see, training data, create data input using CSV. No, what I want to do is I want to get the files. Here's what I want to do. I want to get the files from a specific directory, and I want to make sure that they that it's distinct, right? So system.io, get files. Let's see, what's my source directory? In this case, it should be, yeah, Stamina app. Oh, whoops, that's not the get files I was looking for. I was looking for this one here. Okay. So train files. So train data. Actually, I don't want to take 5. I want to just get them, right? And what I want to do here is I want to check, are these unique? So what I actually want to do is I want to call array dot distinct. Okay. And then I want to call array dot length. Okay. So what I'm doing here is I'm checking, are my bytes files in my train data set all distinct? Okay. And I want to check how many there are. There's 10868. Okay. That's my train data. Now, the weird part here is I don't know. It could have been a mistake on my part that when I was doing the test data, I actually used the train data. So that could have been one of the reasons why, I sort of messed up last time. But again, that's what we're trying to correct here. Now, if we were to look at the test data now, and we were to do the same thing, are all of them, okay, 10873. Cool. All right, so now that we know that all of them are distinct, what we can do at this point is we can rerun this script here, which is going to turn our, first of all, I want my bytes. In this one, I want p-sec, because that's what we had last time. And I want to save it into my train images JPEG. So one thing that I want to do here is cd data drive. Let's see, cd data drive, cd train images. Let's see. Okay, day 637. So sudo remove. Okay, let's get rid of everything here. Clean it out. All right, so test data, test images. train data and train images. All right, so what we're going to want to do now is we're going to want to rerun this on our training data to do the bytes. And at this point, we're going to convert our raw data into images. Okay, so that's not where this goes. Okay, so here we are. So cd home. Okay, and now we want to go to our stream projects and tool stamina. And this is our app file. And just make sure, again, it's the train data and bytes. And then we want to do these things to it and then save it as JPEG in our train images directory. Okay. I like it. cd app .NET build. .NET run. Actually, you know what? I should probably do the same thing for both train images and test images. Let's see, how can I do that? So I want to do it for, let's do it like this for now. So let's build it and let's run it. So right now what we're going to do is we're going to convert, again, our raw files into images. And what happened here? Oh yeah, Tmux is actually pretty bad at. It's pretty bad at this. So let me check here what the error is. cd app. So with Tmux, one of the problems is font size console at 720. Oh, yep, I can actually do that. Let's see here. Is this properties? Properties, font. There we go. Let's bump it up to like 20. Boom. Is that better? Okay. Let me know if that works, and if not, I can make it bigger as well. Let's see here. .NET. Oh, I already had the output actually. So what is it? .NET run. System one or more errors. GDI. I think we solved this one last time. Let's see. Base work. Did anything change here? Oh, still pretty grainy? Okay. Let's see here. Properties. Let's see. Let's bump it up to this. Is that better? A little bit smaller. It might also be that for display purposes, like it's maybe okay, awesome. Yeah, it might be that this, you know, the resolution that this comes off as. Yeah, huh. Let's see here. I'll have to figure out how to do that next time. Maybe to my settings. Yeah, I'll have to look into that. Oh, there we go. Audio. Yeah, I'll have to play around with the settings. But thanks for letting me know. Yeah, thanks for letting me know. I'll look into that though. I think I found a setting that you're talking about. So let me go ahead and after the stream take a look at that. But thanks. I didn't even know about that. See, always learning. Okay, so let's see here. What? What's going on here? Why isn't it running? .NET run. I forgot again that it's not good. .NET run. Nope, not rune. Run. Let's take a look at what our output looks like. Okay. One or more errors. Search a generic error. This is not a very good. A generic error GDI plus. Safe native methods. PSEC module. I mean, I don't. This literally worked last time. So, get files. Dot. Iter. Yeah. I pass in my file path. Get bytes. Image width. Yeah, I mean, there's literally nothing here that would cause it to. Let me see if it does it. If I run that, and I'm gonna, and if this works, it's because for whatever reason PSEC. Okay, so this didn't work. System drawing. Line 42. Okay, so that's this here. .fs program line encode parameters. Let's try to debug this. Let's see what's going on. Actually, let's do it here. And let's set a breakpoint here. Let's see if it even gets there. App fs proj. Next here can opens. Okay. Let's see here. Can we run it here? Oh, okay, so that seemed to work. Okay. So it gets here, and then if I step over my files, I should get something with like 10.868, I believe. Yep, 10.868. And then what I want to do is I want to continue. Okay, file name. Okay, what's my file path? Okay. It's fine. Oh, I think I know what it is. I think I need to sudo because I am using sudo .NET run because I'm trying to access. There we go. Okay, so that's what it wanted. It's not very descriptive, that error, talking about GDI and system drawing. It actually was because the data drive is sort of at the very top level, and I needed sudo privileges to run this. So, okay, that makes sense. So, kicked it off. Oh, but if I remember correctly, we did this. We did this with sec, right? And we wanted psec because it should be more performant. Okay. Or at least it should utilize. Yeah. I completely forgot about that. But we want to do psec because it should utilize the resources better. Okay, so, but in the meantime, let's actually cd data drive, train images, remove, okay, sudo remove. All right, So train images. Okay, this is good. CD stream stamina. CD app. .NET builds. So psec. Let's just make sure that it builds, and let's run it. Sudo .NET run. Okay, so while those files are being processed, which might take a while, I want to take some time. Let me just make sure, see my resources. Beautiful. Perfect. So I want to take some time to kind of contribute to a few, well, not to a few, but to a open source project that that I've been meaning to. I actually have a few things that I have assigned to me, a few issues, but I haven't gotten the time. So while this is going, let's kind of switch context a little bit, and we're going to work a little bit on this project, which if you haven't heard of it, it's a really neat project. Alexander sort of put it together. Oh, actually, before I go into that, I literally just dove into this thing here. But if you're interested, let me sort of go to here to the YouTube. And it's taking a while to load. But let's take a look here. So John, he I believe it was last week. Last week, he did an interview, but it was published yesterday. John Wood, he had a chance to interview and set up an interview with a few members of the ML.NET team. So let me see if I can find it. You would think that even though I'm not using my local resources to process this data, that it would still be able to. There we go. Oh, these are lies. So last time I think it said that it had 70 something views. I don't know why YouTube is underreporting here. Now it says 43. Anyway, I'll paste it into the chat. So yeah, it's just a few folks. A few folks from the ML.NET team just got together, PMs and a few engineers, and they were, just talked through a few questions in terms of like what the future of ML.NET looks like, some of the focus, and some of the things that were mentioned, right, as it pertains to ML.NET is, and I think I've said it time and time again. It really comes back to community, right? It is an open source project, but just because it's open source doesn't mean, you just because the code is out there, it doesn't mean that there automatically is a community and that there's a sort of a contribution pipeline or events, or it takes time, and yeah, it takes some time to build a community around these types of projects. And we've seen that, right, since the conference. There's been a sort of a tick up in activity and buzz around ML.NET, which is great. So you just got to keep that momentum going, and just continue to build upon and try to make that better, right? Because on the engineering side, right, like there's only so many resources that and certain things that uh, that Microsoft could look at, right? And an interview kind of goes through that, where there's only so many resources that could be allocated towards this, right? And there's got to be a focus, right? Like ideally, yes, you would dedicate your resources towards various things, right? But the reality is, yeah, more examples of Sharp, would that be a fitting contribution? Yeah, that actually would be a great contribution, in the machine learning samples. So so um, there's already a folder here in machine learning samples. We can actually walk through that. And GitHub looks completely different. I don't know if you had gotten a chance, you folks have gotten a chance to go through GitHub, but it looks very different. It's still taking me a while to kind of wrap my head around. So if we are here in the machine learning samples, yeah. Um, Now there's no saying that. Well, actually, let me take a step back. So if you look at the samples here, right, there's different types. There's just sort of the home page, if you will, right, and it tells you the different type of examples that there are, and it tells you the languages that these examples are written in, right. Um, and while there is no sort of um, mandate, if you will, right? There's no mandate that, oh, they all have to be one to one, or you have to, if there's this example, then it has to be in F sharp, or you can't build your own F sharp only samples. Um, there's no mandate that says that. Although, right, like if there's already, for example, in this one, the MNIST, right? If there's already a C sharp example of this, but there isn't an F sharp, a good way to contribute here would be like, okay, well, how can we sort of bring this particular example to parity and show the F sharp version of it, right? So yeah, I mean, in terms of contribution, that would be great. And the way that you can do that, right, is you can, or how I would go about it is, for example, time sales forecasting. I think this was a pretty big project, and I think that, yeah, it's an end-to-end app. But I mean, again, right? There's no. So what this uses is it uses Razor pages, right? Uh, I don't know if you could do Razor pages with F sharp, but yeah, I don't know if you can. That'd be a good question. But anyway, but essentially what this is, right? It does sales forecasting, and it does this inside of a web application. So you can think of, right, using something like the safe stack to so highlighting the safe stack and showcasing um, the F sharp way of doing this, right? And you would do, maybe it wouldn't look the same, but you would maybe put something together that's very similar, right? This is a little bit more complex of an example, uh, but let's see if I can find a simpler. Right, exactly. You still do MVC. You can do exactly. It doesn't have to be exactly. So that's the thing, right? Like, although it's showcasing the scenario, it doesn't have to be, like I said, a one to one, right? Like it could be the F sharp way of doing it, um, but it could be the F sharp way of doing it. But again, so long as it sort of fits, if you're looking to sort of contribute and bring these examples to parity, um, you want it to look somewhat similar, or do the same thing that the C sharp version does, right? Um, so that's one way, right? Exactly. It's try to make it nicer in C sharp one, show why F sharp. Yeah, absolutely. Yeah, it, yeah, absolutely. Um, and you can do the F sharp version of it, right? And you can sort of, like I said, bring it to parity. Now, if you wanted to go and make your own F sharp sample, that's good also, right? And what would fit here would be, again, it wouldn't be recreating one for the sake of recreating it. It would be something that's not there now, right? So, for example, let's see, ranking, computer vision. There's object detection. Let's see, what would be a good example of this one? So it's binary, multi-class, recommendation. Yeah, there is a style transfer. But yeah, you're actually totally right. So style transfer is one that's not here yet. Oh, actually, okay, that's one. So thanks for so it's not style transfer, but one that's not here yet, right, is NLP. Exactly. Onyx models, exactly. So there's already the Onyx use case, right? But it's the Onyx use case as it pertains to object detection, right? Which is great. But NLP, right? Like, there's been just so much that's been happening around the NLP space, right? With Bert, Roberta, GPT, right? The GPT set of transformer models. So there's been a lot that has been happening in the NLP space, and you could take advantage you could take advantage of these models, as long as you can find an Onyx version of it, right? So as long as you can find Vert in an Onyx version, you can most certainly take advantage of that and try to build a sample around that, right? So those will be the two ways of contributing. One way is for examples that are already existing. If there's not an F sharp version of it, try to create a sample that does something similar, uses the same data set, and has sort of the same functionality, for at least for end-to-end applications, right? That has the same set of functionality as the C sharp counterpart. That's one. Two, it's a completely different scenario that's not here. Again, kind of like Onyx, right? Or, well, there's Onyx here, but it's for object detection. But perhaps, working with NLP or any other model, like style transfer, working with any other type of task, that's not already in here, right? So yeah, so that's how I would say that I would contribute. So, but going back to kind of like, the future of ML.NET, like, it was mentioned that there's only so much that could be focused on, right? At the end of the day, it is an open project. So, whatever the team may not be focusing on at the moment, if it's a feature or something that you think that the community will benefit a lot from having, and you see that, at the moment it's not a priority, you're more than welcome to contribute to the actual to the repo itself, right? So you're more, and the team, they're very open, they're very helpful in that manner, right? So they'll help guide you through contributing and things like that. Um, so there's that, right? And let's say, like, you're okay, fine, you're like, hey, I don't feel comfortable going in and touching the code, or messing around with the code. um, Another way to contribute, or at least let the team know, hey, like, this is something that would be nice to focus on, it would be a nice feature to have, is just open an issue, right? So go to the issues here, and you can just say, like, like a feature request. For example, there's retrain custom TensorFlow model feature request, right? So what's this one look like? Mm, retrain custom TensorFlow. I design Siamese sign network in Python, train the model. Let's see, can I get output the model, but it's on train, schema mismatch, okay. Output booleans, but a vector. Train my binary, recently train the core instead of Python is test speed improvements, or else something independently of Python. Yeah. So I think that they're requesting the ability to retrain a custom model, right? So I think currently you can only use one of the architectures predefined by the image classification trainer, right? So yeah, I opened this one a few days ago, right? And this is like a future thing, where, if you saw the at build, the C sharp 9 presentation records are going to be coming to C sharp. So maybe, yep, all right, I'll catch you later. Take care. So there's different ways that, individuals can contribute to, and provide feedback to the team to let them know, hey, these are things that you should probably look at. Again, if the team isn't, focusing on that particular feature or request at the moment, the code is open, and you can most certainly go ahead and build it yourself. So yeah, the long story short of all that is, community is really what's going to keep driving this project. And, the stronger the community is, then the stronger and the better that the project becomes. So, these streams are sort of, I hope that these streams help, but at the same time, there's other ways that we can grow the community and contribute to this really awesome project. In the meantime, let's see where we are here. Okay. So that's going. And while that's going, let's just make sure. Train data, train images. Okay. All right. So if you haven't checked it out, I pasted it into the chat. Check out that interview. It's really really insightful. Very nice. I really liked it. So thanks, John, for putting that together. And speaking of community, speaking of projects, right? One of the projects that's been sort of created over the past few weeks now. Yeah, probably over the past month or so. Is this one called MLOps.net, and thanks for pasting that. Let's see. So MLOps.net. Now, MLOps.net is exactly what it sounds like. It's MLOps, a package, set of packages, libraries that allows you to do MLOps for .net. Um, so Alexander and a few community members have been actually working on this thing. You can see he was busy 2 hours ago, plugging away at it. Um, so what this allows you to do is now, so as you're doing, so just to kind of like take a step back, talk a little bit about what MLOps is. So MLOps is basically like DevOps for machine learning. So with DevOps, right, it's actually hard to define what DevOps is. Is it practices? Is it culture? You know, there's many ways that you could probably define it. But one way to define it, right, would be basically the operationalization of your engineering and software development practices. So one of the things could include building continuous integration and continuous deployment pipelines, right? So CI/CD pipelines. And what that does is, you can in a sort of an automated or semi-automated fashion, you can one, take care of source control. You can build your projects, right? So make sure that they're building with any new changes that are being checked in into your source control. Make sure that your builds work, that your packages, your software doesn't break. You can automatically test your projects, right? So you can evaluate how whatever unit tests, integration tests, whatever it is that you need to do for your software. You're doing it you're doing it on your project, right? And so that's part of the continuous integration. And then the deployment piece, right, is once you've built it, once you've tested it, you have somebody say, hey, yep, this is ready, it's good to go, let's release it, right? So that means publishing it up to somewhere like NuGet or NPM or wherever it is that you are publishing your artifacts. Or it may mean deploying an application, right? So, for example, if it's a line of business application or an end user application, right, it might mean deploying an update to that application to the client devices or to your clients, right? So, what this gives you, number one, is it gives you sort of reproducibility. It gives you transparency, right? So if you if your soft if there's problems with your software, you're able to say, hey, okay, we're on this version of the software. Well, okay, well, what were the steps that were taken to get to the step, right? Like, what did the build step look like? What did the test look like? Did it pass? Who approved this, right? So you get that sort of reproducibility where you can roll back. You can sort of, if you need to rebuild a version of software, right, with the specific dependencies and things like that, because you have some sort of log of all the steps that takes place. You're able to audit, as well as you're able to recreate what your you're able to recreate how that particular version of the software is built, right? Or reproduce bugs, for example, that sort of thing. So you get that, you get the transparency again, right? Because you get to see the full end to end, kind of what it looks like and how the software is built. So it's really great, and within software engineering, it's really been it's a practice that's continued to be sort of adopted, right? Which is great. So how can we take with machine learning it's very, as you're building these things, there's a workflow, right? So you get your data, you build your model, write code to build your model, you train your model, you evaluate your model, and then you deploy it, right? So very similar to software. There's a few things that might be a little bit different, but for the most part, it's the same, right? So in your build step, instead of build, right, you're not necessarily building software, although you kind of are, because you need to make sure that the code that you're going to run to train your model builds, right? But really, the build step, that would be the traditional build step for software, right? In machine learning, it would be the train step, right? For test, it would be the evaluation, right? You want to make sure that your metrics, your accuracy metrics, your performance metrics are sort of in line with what it is that what you want them to be. And when you deploy it, again, that could be just putting your model up in some sort of file share or blob storage or anywhere else and publishing it there. Or it could also mean deploying it inside of an end user application, right? So, for example, if you have a web app and this web app makes kind of like Amazon, right? It makes recommendations in terms of what people would be interested in buying. Perhaps you deploy your model alongside that application, right? So, what MLOps.net allows you to do, kind of taking it back, is it allows you to perform those things for .NET, specifically for ML.NET, for ML.NET models, right, or for ML.NET projects. Now, there are other systems out there like MLflow, right? There are other systems out there like MLflow, but they they have a more Python centric approach to doing things, right? So what happens there is that you can sort of take advantage of it you can take advantage of some of the features from a .NET standpoint, but you can't really take advantage of all of it, right? So particularly like if you're trying um, particularly if you're trying to store your model or register your model, which is the phase where it's like, okay, I'm done with this particular version of the model. I think it's good, so let me save it somewhere. That way I have a version of my model, right? So the model registry piece, it's not very that story isn't very clear, right? So what happens? What do you do? Well, you either got to work around, you got to find some other mechanism for registering your models and for versioning your models, right? And that's sort of where this alternative comes in, where it's like, okay, well, MLOps.net, you can take full advantage of doing that, doing those, both the metadata, like the logging of metrics, the logging of parameters, but also the model registry piece, and you're able to do that all using .NET code, right? And best of all, you can take advantage of it with ML.NET models, and it works seamlessly with ML.NET models. Furthermore, the other thing that it does is, so if we go into the source here, you can see that there's different ways of building this, or different places where you can store your metadata, as well as your models, I believe. So one would be Azure, right? So Azure Blob Storage and Azure Table Storage, SQL Server, right? So if you want to store it on SQL Server, you can certainly do that both on well, I don't know this implementation, but essentially, I don't know if it's the local version of SQL Server, or if it's the on like if it's on prem. I would assume that if you're able to pass in a connection string, you can use both local and local, as well as sort of remote SQL Server deployments, or instances. And you can do SQLite as well, which is nice. All right. So there's a few things here. I had it here actually. There's a few issues that were assigned, or that I kind of assigned. Um, let's see. Is there a way to do it by project? No. Assigned. Unfortunately, there's no way for me to do that. But but one of the things that we can do here is take a look at this one here, right? And let's see, in a shore, as we get started, I think some of this is going to be added too. Let's see. That makes sense. To them. Okay. Comment. So this is documentation sort of task, right? And what we're trying to do is we have examples in the MLOps.net, right? So take a look here. And I'm probably going to get off in like 15 minutes here at 11:15. So if we take a look here, there's examples, MLOps.net examples, and there's binary, multi-class, and regression. And take a look at this here. These themselves don't have readmes. But in this case, what's happening is this one is using SQLite. And what it's doing is it is training an image classification model. Let me see something here. Oh yeah, the data's there, so you can run standalone. You can run the standalone. There's a Titanic data set. So what we want to do here is we want to add a little bit more data. So if you go here, right, if you go to MLN examples, you open up binary classification. There's nothing really telling you what this does or what it's good for, right? So we want to clean that up a bit, make it just so that whoever's coming here can kind of get an understanding of what this is and what it's trying to do. So for example here, what is this? This binary classification. Again, it's using SQLite or SQLite. We are using the Titanic data set, and we are trying to predict, what's our label here? What is our label? What are we trying to predict here? That's the features. Right, but what is the label? Yeah, so here I'm just having trouble trying to understand what exactly this is. Okay, so there we go. Entities, model input. Okay. So what's our label? Survived, right? So we're trying to determine whether someone in the Titanic survived based on several other inputs. Okay. So that's the type of information that we like to include here. So if we take a look, let's see, I think I have a version of this open, and I think it might not be the latest, but that's okay. Let's see here. CDNO ops. All right, so I have mlops.net. I'm putting Visual Studio Code to it. While Visual Studio Code is opening, let's check on this here. All right, it's still going. Okay, let's see here. Okay. It's taking a little bit of time to open up. All right, now I need to get the latest version of this. In the meantime, while this is going on, let me actually close out of this because I no longer need it. I no longer need to be connected to my VM, right? So let me just close out of it. That way, it's not taking up resources. Okay. So here we are. No source control. So there's mlops. There's source. Yeah, you can tell I have like an older version. Let me see. Let me take a look at why it's not working. Git status. Yeah, so if I git branch, okay, git checkout master. So git branch. Let's see here. Git fetch. No, not git fetch. What I want to do is git branch. Let's delete some of these branches here. 48. Okay, branch D, issue 48, and then we want to do the other one, right? So LQ dev. Fix. Oh, right, it's not gonna. This is not git bash, so I have to type everything out. It is super slow. That's okay. That's okay. Typo. Okay. All right. So branch. Wow, this is just super slow. Let's see, what can I close here? Task manager. I mean, I wouldn't be surprised if it's OBS, the one that's hogging all my resources. Oh wow, it's actually Edge, the one that's like taking up all my memory. Okay, so Edge, let's close one of you or several. Okay, all right. So not yet. Is it better? Let's see, git branch. A little better. All right, so what we want to do now is we want to get up to date. So git fetch upstream, right? So we want to get the latest changes from the upstream branch, which is Alexander's, the one or basically Alexander's version of the files. And there we are. I probably should have. Okay, git pull upstream master. Okay. And let's pull all those changes in. Nice. There's been a lot of work that, again, it comes back to community, right? Like community is the one that's driving a lot of this. So this is really awesome. Okay. So git checkout B, and what was the name of this issue? Let's sort of stay consistent. So one of the things that I like to do is, if there are certain things that I'm working on that are associated with a particular issue, right? So in this case, it's what issue 105, right? I like to tag it that way, that so that I know it's not, and maybe not as descriptive, but I can be descriptive in the PR, right? For in terms of looking at the branch and the, at least I can associate it with the issue by looking at the branch name. I can say, oh, it's issue 105. So I would go to issue 105. I can see what the issue looks like, and then any PRs that I open with it, I can also sort of link them, right? So that's what I'm going to call my new branch, git checkout B. Actually, let me just make sure git push origin master. Let me make sure my version, remote version that is up to date. All right. You typically don't have to do this, but I like doing it. And now that we're in sync, now we want to do git checkout B issue 105. Right? That was 105. Yes. All right. So there's multiple ways that we can go about this. If we go here to our examples, binary classification, what we want to do is we want to add readme, RMD, right? Let's see. Binary. So we want to start with heading 1, call it binary classification sample. We want to give like a brief description of it, right? So you want to say man, sample. It is so slow. All right, so I want to give a description. This sample uses SQLine. Sample trains and image classification. A binary classification model. Not image classification. Classification model. Trains an image classification model. To predict whether passengers on the Titanic are likely to survive based on a series of inputs. Okay. SQLite is used as the data store for logging metrics and saving the model. Is that right? Let's see. What does this do? So if we were to take a look here, let me kind of shrink this a bit. Let me move this here a little bit. Save train model. Where's it saving it to? It uploads it. Okay. Yep. Okay. So it uploads it for metrics, and the SQLite is used as the data store for logging. Okay. So the data set. The data set is, so here we would want to, so in the data set section, we want to include information about the data set, like where does it come from and things like that. This data set, the data for this sample can be found in the data directory. It comes from the Titanic data set. Let's see. So if we go here, Titanic data set, Titanic data set. Let's see. Is it part of what is it part of? So it's part of Kaggle. I guess the question is, what's the source of it? Oh, it's 11:15. Okay. Okay, so maybe we can add some metadata here, right? So in here, task, backend, data store, right? So here, what we can do, just add a table, and task is binary classification. And then data store SQLite. Okay. Let's see. What does it use for the features? Excuse me. Excuse me. All right, so these are the features. Let's see. So P, okay. Inputs. Well, it doesn't matter. Let's see. What I want to know. Which metrics are evaluate? Oh, all of the metrics. Interesting. Okay. And that would include what? That's interesting. Okay. Log metrics async. I have to look into what this means, but sure. Okay. For the samples we found data directory, it comes from Titanic data set. Okay. Actually, let's do without this for now. I actually do have to log off. So let's go with this for now. Let's check interchange, right? Initial commit. Okay. And we want to push this up to our local or our version of the our repository. And once that's in, we want to open up the PR, right? Let me actually just make a few changes. So one, build project, run the project. We might want to talk about any prerequisites, right? Prerequisites. I think this is using .NET Core 3.1. So if you download this, let me see here. C program.cs binary classification. All right, so it uses so prerequisite would be the .NET Core. Oh, come on. Be the .NET Core SDK. All right. Whoa. Okay. As a prerequisite, .NET Core SDK 3.1. I don't know if this will do anything, but .NET Run. .NET Build. Okay. All right. Let's see. So let's go here. Let's see. Added what? What did I do? I added build and run instructions. Okay. Let's go ahead and check those changes in. And once that's done, now we have two things to go here. And I want to push yes. Push my changes up. If we go to GitHub now to take a look at this here, we actually want to go to my fork. All right, so forks 13. To mine. Nope. Go here. To my fork. Okay, issue, compare, and pull request. Issue 105, resolves number. Fixes number 105. Yep, description. Add readme to, let me see, to do, okay. Link to examples from wiki. Add. What else is there? So there's some examples. There's multi-class and regression. Okay, so add multi-class. So it'll be finish what? Binary classification readme. Add multi-class classification readme. Add regression readme, and then link to examples from wiki. Okay, so let me actually put work in progress, and it's going to be update. Let's see, add documentation, 2 samples. Okay. So I set it as work in progress because we're not done with it yet. That means that it shouldn't be reviewed. Um, we added some of the stuff that we still want to do. I am assigning it to myself because I'm doing it. In terms of label, it's documentation, right? And yeah, so awesome. We'll keep work. There's actually so what I'm gonna try to do is I'm gonna try to finish up making the changes or I'm gonna try to finish up going through the images and converting them so that I'm able to use them for training a model later down the line, and then I'm gonna use that model to score my test data, and I'm gonna try submitting it again, right? And on Monday, what I'm gonna try to do is I'm gonna try to share what the outcome of those efforts were. I'm hoping that that it goes better than last Wednesday. Um, and on Monday, actually, what I want to do is I have an idea for a new project. It's really exciting. It's gonna bring a lot of things into sort of we're gonna learn a lot. Let's just put it that way. We're gonna learn a lot. I'll talk about it on Monday when we sort of stream and introduce the project and talk about what it is that we're trying to do. It's going to be a little bit different than this one that we did with Stamina, right? So with Stamina, we had sort of a clear goal of building a machine learning model or a deep learning model for training or for identifying classifying static malware analysis. We had a data set, we had you know sort of a white paper that kind of showed us more or less how we wanted to go about building these things. This new project that we're going to be starting on Monday, it's not going to be so much focus on the machine learning side of things. There's going to be there's machine learning components, but building a machine learning model won't be the end goal. The end goal is how can we leverage this particular system that we're going to be working with to build machine learning models, any machine learning model. So we may just do image classification, something simple, right? Because we want to just be able to get comfortable with the system as opposed to uh, worrying too like being focused on the machine learning model that we're building, right? So we don't care too much about the machine learning model we're building. We just care about how can we leverage this system to train our machine learning model, right? So and it's going to bring a lot of technologies together. It's going to bring a lot of things to play. Maybe perhaps even MLOps.net will be using it inside of there. So yeah, I'm really excited for Monday. I'm really excited for this new project. Not to say that Stamina wasn't exciting, and I learned a ton doing Stamina, but I've been wanting to sort of take a look at this new project. But yeah, thanks for stopping by, Jim. I appreciate you sticking around. Um, but yeah, so I'll see you all Monday. Have a great weekend, and we'll chat some more then. I'll let you know how Stamina does. Thanks. Talk to you later. Bye.